Hello everyone. Well, this short video is about graphs and what are the basic elements of graphs, how you have to make it. Well, whenever we measure something in our lab or have some data that we have to plot, so here I have a table, X and Y table, where Y is some data that depends on X, like how Y changes with respect to X. I have taken here the example of velocity and time, like how velocity is changing with respect to time. So this is an acceleration curve. So let's begin with some elements of the graph. Let me introduce you to the title. The title is some suitable name you give to your graph to identify it, and it tells a lot about the graph. And then you choose your axis range, like how much data you have. You have to choose the axis range depending upon the limits of this data set, like you have some upper limit and some lower limit. So depending on that, you have to set the range, like your x. Let's begin with x. So x starts from 1 and ends with 6, so this is the limit for x. So you have to make divisions like 1, 2, 3, 4, 5, 6, etc, and you have to just take one extra cell of this graph sheet. So what is cell? This is the cell of a graph. This thing, this purple thing, is a cell, and this cell consists of 10 divisions, and you have to count on these divisions. Like if your value is 1.9, so there is 1 from here. So since this is origin 0, so this must be 1, and on y-axis here this must be 1, so 1.9 must be like 0.1 is here, so it's 1.1, 1.2, 1.3, 1.4, 1.5, 1.6, 1.7, 1.8, and 1.9 here. So this dot is somewhere here at 1.9. This is 1 comma 1.9, a coordinate on this graph. So you have to choose a suitable range, and if you can't find a graph where you have very off limits, like your limit starts from 10 and it ends with 15, so you can also use the concept of kink. You can make a kink on your graph. For example, if this value had started from 10 instead of 1.9, so here must be 10. So you this actually, this data set, this curve must be very much above your graph sheet, since it's starting from 10 and ending with 50. So what you do, you use the concept of kink. You make a kink sign here on the graph, and this kink sign represents that this all region has been shrink down or has been folded down. Like if this is a sheet of paper, you can shrink it down by folding it. So this is the concept of kink. Next, there are axis labels. You must be familiar with axis labels. I have labeled my axis with t, time, and v with velocity. These are axis labels. And then there comes the scaling, how you scale your graph, and you have to mention your scaling here on the top. So at x-axis, I have chosen 1 centimeter equal to what? At x-axis, I have time. So I have chosen it like this: 1 centimeter equal to 1 second, since this is in seconds. I can stretch my graph as per my convenience and mention that scaling here. I can choose 1 centimeter equals to zero point 0.5 if I want to stretch my graph like this, and I don't want uh, 1 to come here. I instead want this 1 to come here. I can stretch my graph and mention the scaling here, that I have now chosen this 1 centimeter block equal to zero point 0.5 seconds. Same concept I can use for my y-axis, and this part is called the scaling of the axis. Well, then there are legends. Well, legends represent different data sets present on a single graph. For example, if this data set would have consist of a data set represented by blue color and another data set, let's say, represented by green color. So I also need to mention the legends, and I mention legends here at the top where I have mentioned this stuff. So here I mention legends and I just make a box. I mark the symbol or things that represent that data set. So here green color represents graph 2, so I mention here graph 2, and the blue represents graph 1, so I mention here graph 1. So these things are called legends. And then there's stuff people call least count. And while choosing the least count, you should remember, like while I was doing the scaling or stretching of this graph, I needed to stretch it like this or that. So I should not stretch it in multiples of 3, in multiples of 6, or other numbers that are not divisible by 2 or 5. I should be careful enough that I choose either 2 or 5 steps of 2 or 5. I can also shrink it like I was stretching it. I can also shrink this thing. So while shrinking it, then I have to be careful about how I am dividing, and it is kind of prohibited that we don't shrink it by one third or one sixth, etc. We either shrink it by one fourth, one half, etc., or maybe one fifth, because there you are actually not making use of irrational numbers. You must be aware of the concept of rational and irrational numbers by now. I believe that you are. And even if you don't, just be careful and follow these steps, that while shrinking, instead of stretching, while you are shrinking the cells of this graph and is mentioning your scaling here, you must use one fifth, one fourth, one half kind of factors. Well, I have told you about the manual graph that we usually use in lab, but there are certain tools that we can use as an alternative of our manual graph. So the tools are MS Excel, very much famous tool. You can use an Excel sheet, and there is a part in Excel sheets. It gives you options of graphs and plots, so you can use that. There are scientific tools like Origin, and there are programming languages like Python, and there are online tools to visualize difficult graphs or equations and curves like e to the power minus x or x square or k e to the power minus x square, certain things. That's Desmos. There are tools that work on Linux systems, uh, like XMGrace. Other than that, these tools which can work safely on your Microsoft Windows operating system. There are tools like these XMGrace that you can use for your Linux based workspaces, and you can use the rest of the internet, since now we have the facility of internet, and there are a lot of tools available there. You can use those plotting tools, and last but not the least, you can use your siblings and friends for the same. Thank you guys, see you in next video. Wait. I forgot to tell you something. Well, before plotting your data, you must round it off accordingly. Like, you can't plot 1.95 on this data set. You know that, because you have only divisions like 10 divisions between this from 0 to 1. So this number on the second decimal place, which is 5, this doesn't comes or lies on this graph sheet. You can't precisely like point it out that here it is like 1 2 3, so this was a 2.95. So you can't point it out here. So it is a better practice, a good practice, to round off your data to your suitable scaling before plotting it. If you had divided it like in this regime, like now you can safely point out that this is like 0.95 if it's starting from here and ending here. So you can point 0.95 here on the graph. But if you are um, using scaling like this, where 0 starts from here and it ends, and the one uh, lies here, you can't plot 0.95 on this data set. So be cautious, be careful, and thank you.